So, with that, some notes on the Linux kernel. First off, this is the source code tree, and to get the Linux source code tree, you just need to get on Linux. Linux has a GitHub repo, which you can all check. If you just search in Google or in whatever your favorite search engine is for the Linux repo GitHub, this should take you basically to the source code of the Linux kernel. And there are many variations of them, but the variation you want to check is the Linus Torvalds main tree, because this is sort of the uh, Linux that everybody uses. The other variations are company variations, or some people basically branching from his source tree, but you want to go to this source tree. And looking at the source code tree, you will find that these are the folders in the source code tree. And these folders basically are self-descriptive in the sense that if you're developing, for example, a new part of for the networking, then you probably would find a lot of what you want in the networking subsystem. Let us go basically uh, discussing one by one. So the first directory you will see in the Linux kernel source code tree is the arc directory, which is basically architecture specific sources. In last lecture, like last physical lecture, we talked a bit about how the actual architecture can uh, affect the ways that your operating system would work. We actually even talked a bit about that in a few of the previous video lectures on like assembly code and its role in the Linux operating system and in operating systems in general. We talked about the hardware abstraction layer, and these all you will find in the architecture specific source. Okay. Then if you follow, the second one would be the block directory, and this is where all block IO operations are developed. So basically, if you have a block IO device, and we're going to talk a bit about block IO devices later in the course, you typically will have some of the source code in the block IO uh, directory. And when, of course, there are some things that will be across multiple directories. So you might have things um, that are spread among many directories, and that is also something that we're going to cover a bit. The third one is the directory, and there you have all the cryptographic API, all the different implementations for cryptography functions are in the API. You have the documentation, and this is a very important directory for us, because this we'll be basically using this, as we are not going to use the book. And this is the kernel source documentation. You'll find there documentation on almost every single thing in the source code tree. The documentation, as always, lags behind, so it's not up to date. It's not up to date, meaning that you might find lines of code that you will not find documentation for, even files that you do not find documentation for. But nevertheless, uh, I would say that this is a great source from which you can actually learn. My video lectures will point you to things so that it makes it easier for you guys to navigate through this huge amount of code. As we saw last lecture, there are like more than 25 million lines of code in the Linux kernel now. So that's a huge amount of code. But at the end of the day, I'll just act as a guide, and you guys will figure out things as we roll, basically. The next directory is the drivers directory, and this contain the device drivers. We talked quite a bit about device drivers. Then there's the firmware, and this is more like certain drivers certain devices do not just work with drivers. Basically, the drivers would be a higher level code, sort of, compared to the firmware. Firmwares are basically very low level code that is needed by some certain drivers to run actually. Then there's the FS, which is the file system directory, and this is where all your file system operations, or many of your file system operations, are. Then you have the include directory, and these are all the kernel headers. If you want to include anything, then it's probably in the include directory. There's the init, which is the kernel boot and initialization. This is sort of what we were talking about when we were talking about the boot sequence, what happens when you boot your device. This is basically where that type of code is. There's the IPC, which provides you services for inter-process communication code among the different kernel subsystems, because you need IPC among the different kernel subsystems. There's the kernel itself, which is the core subsystems such as the scheduler. And as you see, well, when in Linux, in the Linux world, when they talk about the kernel directory, they actually mostly mean the scheduler directory, because this is where the heart of the kernel is. Then you have some helper routines in the lib directory. You have which is the memory management subsystem, and the virtualization layer for memory is implemented there. The net directory is where all your TCP/IP, whatever code whatever protocol you're going to use, it's probably part of the net subdirectory. You have some code samples to basically show you, if you're starting with kernel programming, you would go and check, okay, there are certain design patterns that they follow, there are certain rules that they do as kernel programmers. There are some scripts that are used to build the kernel. We will actually learn how to build the kernel, not in this lecture, but probably yeah, I'll provide you with some material. I don't think that I will even cover it in person, and will help people if they are not able to build it. There is a Linux security module, and there is a difference between cryptography and security. I hope you do know this difference. If not, that's a completely different field in computer science. And then there's the sound system subsystem, which is basically your sound. There's the user USR, which is the user space code. We've been talking about user space versus kernel space. So this is where your user space code would be. And then there's the tools subdirectory, and tools is basically collects a group of tools that are very helpful when you're developing or building the kernel. Okay. And oh, I'm just trying to get to the next slide. I'm sorry.